That would be so funny.
Is that not awesome?
All right.
Listen, what if they tell us when I don't mind?
Have you
Okay.
done
All right.
You're 11.
Okay, hey, section 2.2, this is kind of the last day of it, because, you know, we're going to get homework on it today. We'll kind of move on to the next section tomorrow. It's pretty straightforward. The actual section itself is based on polynomials and rational functions. It's quadratics, but it's how you look at it, whether you know if it's a polynomial or some type of fraction or whatnot. So that's kind of the idea. Obviously, we're dealing with quadratics and problem solving, but the big thing today is like, can we do practical application? Okay, can we apply this stuff and actually problem solve with it? That's kind of the idea. That's our goal today. So you want to know, like, what are we supposed to be doing today? Can you do a quadratic? Can you use a quadratic and actually solve a real problem with it? And you know, in the middle of it, we're still doing all the stuff we normally do with quadratics. You know, complete the square, figure out the vertex, you know, figure out you know, where that thing is hitting the x-axis, what x-intercepts, y-intercepts, and all that good stuff. But we're actually like problem solving in the middle of it. So that's kind of the goal today. We're going to go through a bunch of problems with it. So I'll just kind of refresh your memory on like what the standard form is as we go. You know, how would we graph that? You know, which direction we're head. And so I'm going to do little things, but we're going to just apply them to actual problems here. So I picked some problems around like page 300-ish, like 299, 298, kind of that page. But I picked some random problems that we were going to talk about. Now, we did a problem on Friday. It was kind of a story problem, talking about just basic numbers. I'm going to kind of refresh your memories with that. So here's the idea. So we have a pair of numbers whose difference is 10. So two numbers, they differ by 10 in spacing. Okay? I want to find the product that is as small as possible. The smallest possible product when two numbers differ by 10. I know some people look at it and go, that could be anything, really, because you're picking two random numbers, and you're going to multiply them together, that's a product, and I want to know what the smallest answer could be, which is weird. It is an actual, like, there is one set of numbers that makes that thing possible, that, like, the lowest possible product. And a lot of people are like, just pick negative numbers. Yeah, but when you pick negatives, they cancel each other out, and it makes positive. So there is an actual, like, number you should choose. Okay? Now, if we don't know what they are, we always pick the first number as x. You always pick a variable for it, right? So my first number is x. The other number, since I'm looking for the product as small as possible, the other number will differ by 10 from it. So like, whatever x is, you subtract 10 off of it, and that's the other number. So this would represent the smaller number. This will represent the bigger number. And it really doesn't matter the order we put that, because we're going to multiply them together. But that's the idea. We're taking the product. That's the idea. We're finding the product of these two numbers. So we're multiplying together, and they differ by 10. So whatever this number is smaller by 10. And this will be the product. This is my function. Now, how you figure that out? You have to like read the clues. They're telling you what they differ by, so you can kind of set your two variables. And then you have to read, are they adding them together? Are they multiplying them? Are they dividing them? Whatever they're doing, or we're doing a product. Okay, so I'm going to replace the f of x with a y. Now, just before I get started here on this particular problem, the y here represents the product. So when we find the final answer today for this problem, the y number for my parentheses, my product, that y number is the product. It's the actual answer this problem is looking for. What is the smallest possible product? That's the y number. It will be the actual smallest number possible. The x number we're going to find is this number. It's actually one of the options. It's one of the pairs. Okay, it's the first number in that pair. So that's the idea. Some people like forget like what numbers you're actually finding here, like what the coordinate means. The y number is the product, because how I know that, we multiply these together to get y. So the y had to be the product number, had to be the answer. Okay, so but if we actually do the work here, we're going to multiply these together, so that makes x squared minus 10x. Make sense? So it is a quadratic. Do you agree? Like it has x squared in it. So it is a quadratic. It is a parabola because it has a power of 2. But now we have to complete the square. Now, the process of completing the square is to find the vertex. It's not to find x-intercepts or anything like that. If you want to find x-intercepts, you actually just plug in 0 over here for the y number, and you solve for x's. So like factor apart and all that good stuff. Well, it's already factored.
No network did that.
But for my possible problem here, I want to find the final solution. So I do need to find the vertex, like where the bowl actually starts. So that's kind of the idea, finding the pairs.
Oh!
Or not.
No, no.
We're finished.
You find the pair.
That's a cool background.
Yes.
Let's play Super Mario Bros.
Now we're not gonna play any video
Let's
games.
play
Yeah,
Mortal
we-
Kombat 2 in school. That's like
Sonic.
a cool.
Hedgehog.
Alright.
Sonic's a hedgehog.
Pat, are you uncultured? Do you not know
What
that
is your
hedgehog?
Okay. Alright,
Sonic
hey,
is a hedgehog.
hey, alright, so we're gonna complete the square. So what is half the middle?
Oh, boy.
5.
-5, we square it.
24.
Alright, and that's the number we're gonna add to both sides. Now why know I can add 25? There was no number that I needed to factor in front of the x squared. You need to make sure that x squared has a 1 in front. So if there's any number there, we'll kind of see one here in a little while with my other examples today. If there's a number in front of the x squared, you have to factor that off first. So like basically pull it outside the parentheses so you can figure that out. That will affect the number what I'm adding to the other side. You'll see that later. Alright, but this is my problem, and now all I need to do is factor this side apart. And we made that number by taking half the middle and squaring it. So this side should work out like perfectly. The other side I'm going to leave it alone. That's y plus 25 equals, and now we're going to factor this side apart.
Sonic.
This projector is just seriously not.
He just does not want us to complete this square.
It seriously just doesn't want me to do
We
this.
should,
Alright.
shouldn't use the power.
I think we should take the writing on the wall.
Alright.
I think it's kind of saying.
Okay, Nicole, you wanna stand up on your chair and switch the two HDMI cables? I'm just gonna give up on this stupid Apple TV brain.
What does that mean?
Alright, that cord, just unplug it and plug the other one in, that's right above it. The one that's right there, yeah.
I like
Yep.
this blue screen. I could really learn well, honestly.
I'm done dealing with that stupid Apple.
It's like a green screen. We can put
Until they
anything else.
update it.
You just call an Apple product stupid?
Yeah, the Apple TV is stupid,
Switch to Samsung.
so.
Samsung does it worse.
There's only one way to find out.
Can't handle it. The
We need to know.
engineers aren't gonna seriously work on any problems with that on my TV.
So,
Alright, now,
Done.
so I factored that, so I pulled the y plus 25 out. Now when I factor the other side apart, when I pull this other side, this side factors up, and how I know what it is, it's gonna be two parentheses, because it is a trinomial, and it's always gonna be half the middle. So it'll be y minus 5, that'll make the 25 on the other side. But the trick is, it's always half the middle, and that's how I know like what the number is inside the parentheses, because we made it perfectly, where it's half the middle squared for this number, so that's why it's 5 and 5, and it's negative. Okay, so now, when you're looking at it, this thing right here is standard form for a quadratic parabola. It's how you graph it. The number out front of the parentheses tells me if it's stretched vertically. The number on the inside is the x coordinate, so what number goes with the x?
Oh, 5.
5. It's 5, and we always use the opposite of the number.
It's 5.
Now, what's the number with the y?
25.
25, we use the opposite of it,
Negative.
which is negative 25. This number is the x number I was looking for earlier. It's the first number in the pair. The second number, the y number, that's the actual product. So the smallest product you can get from two numbers that differ by 10 is negative 25. That's the smallest product you can possibly get out of there. So now the two numbers, in fact, if you want to know what they are, it's 5 and negative 5. These are the magical numbers that will give you the smallest possible product when you pick numbers that differ by 10. So it doesn't matter. Like some people are like, how's that even possible? Like what if you pick negative 6? Well, if you pick negative 6, then the other would have been 4, and this will make 24, negative 24. That number's technically bigger than that one. It is bigger, right? On a number line, as you go to the right, numbers get larger. So, if you pick
Infinite amount of points.
if you pick negative 7, negative 3, or sorry, negative 7 and 3, well, that's negative 21. So the number is bigger. So it didn't matter which pair you picked. As long as they differ by 10, this was going to be the smallest product. That's what I love about this stuff, is that it's easy to calculate as long as you know how to complete the square. It always gives you the answer. Now, a lot of people are like, okay, fine, you can find pairs and find the smallest product. But again, we can apply this to anything. As long as you know that we're finding area or we're finding a product, like we're multiplying things together, we can actually do quadratics for any of those types of problems. So let me give you another example of a problem. Does anyone need this?
No.
Okay, I'm gonna get rid of that. Now let's do another example. I'm not gonna do one with numbers. I'm gonna jump right to the chase where we're talking about like actual like practical application problems. So,
have between the two.
So I'm gonna skip the next one. I think that's a number again, yeah, I don't care about that one. All right, so next, an actual application problem. So a farmer has 800 feet of fencing,
Holy.
okay? So 800 feet, they wanna make a rectangular plot that borders a barn. So I'm gonna draw a mock barn here. So here's my barn, okay? There's the side of the barn goes this way, right? There's the barn, all right. That's the side of it. And the idea is that the fence is gonna border it. So this is gonna be my fence coming out. That's my fence, and I'll make it a dashed. So, okay, so there's my fence coming off of the barn, wherever that's gonna go. So the idea is that we're only gonna use a total of 800 feet of fence. And it wants to know what is the largest maximum area that you could have for, whatever livestock you have with 800 feet. Okay, largest possible area. Well, if I know that I have 800 feet of fence, and this is supposed to be a rectangle, then these two numbers have to be the same. The top and bottom, because it's supposed to be a rectangle.
Oh, rectangle.
The other side, since I'm not using this side of the barn, this side over here is whatever the 800 feet of fence is minus the 2 x's. That's whatever's left, basically. And what this will do for us is it will find the maximum total area that we can find. And so it is a quadratic. But again, how I set it up, you draw a mock picture, I put my variables in there, and I don't need the third wall because it's bordering a barn. Now, I may not even have to use the total barn. Okay, because like I drew that picture where it touched the end of the barn. What this problem will give me is it will give me what the dimension should be to maximize area. It doesn't care how big the barn is. I'm not even considering that. Okay, the barn could be huge, could be small, but this will give me the maximum total area with 800 feet of fence, and I can adjust it accordingly. Okay, so how do you find area? Like, how do I find the area of this rectangle? How do you do it? What's the formula for area? Width times length, or length times width, base times height, however you want to think of it. So, base times the height.
Square.
Okay, there you go. So this is my function. This is like what I'm going to work with. It's base times height, or length times width, however you want to think of it. But that's what I'm doing. Notice, I'm not multiplying all three. I'm just taking length times width. That's how you find area of a rectangle.
Oh, yeah.
And, because that's what we're trying to maximize. That's how I know what to do. Like, it's finding area. Like the last one says, I'm finding out products. I had to multiply the two things together. So, on this, we're gonna FOIL this together, or distribute. I'm gonna replace that with a y. So the y in this case is gonna represent the area for me. So that's how I think of this, because this, when I multiply these together, that is area. So this y is the area when I find my final answer today. If I distribute, this is 800x minus 2x squared. So I distribute the x through, and now, like I said earlier, what I was going to do is I was going to do a problem where we had to factor a number in front of x squared. There's a number sitting there, we have to get rid of it, because I want a 1 sitting there. So if I rearrange this to make it look a little bit prettier, all right, so this is a normal quadratic. That's kind of what they normally look like, x squared, blah, 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 blah. All right, now I'm going to factor out the number in front of the x. Because I need to get it to be a 1 before I do this completing the square process. Now, if you want to figure out x-intercepts on a graph, you don't need to do any of the steps I'm about to do, because all you do is you plug a 0 in here for y, and you just solve for these for 0, and that gives you x-intercepts. But I don't care about that. I want to figure out the vertex where the ball starts, the minimum number or maximum number in this case, because that's what this can do for us. So if I'm going to factor out the -2. When I factor that out, this will become an x squared because I divide that off. And if I divide 800 by -2, that's -400. Okay, so that's the idea. And on the other side, I'm just going to leave the y sitting up. Okay, again, why I got the 400? I'm taking the -2 out. So I'm dividing it off. Okay, so I took off the -2. Now I'm going to complete the square. So half the middle. -200. Square it.
That's a big number.
Big number. 40,000.
Just add a bunch of zeros.
And it will be positive when you square it. -200 times -200 is positive 40,000. And then, yeah, what I heard, you have to take whatever that number is, because we made it up, right? We took half the middle squared. You have to take it times the number on the outside of the parentheses, because this is technically being FOILed through. So that number is actually a -80,000, and that's the number I'm putting over here.
Holy mac.
Holy mansion.
Okay. So, again, how I got that 80,000, I took whatever that number we just made up, the positive 40,000 times the number on the outside, and then I put it on the other side.
Holy fans.
Yet again, I'm not adding 40,000 because that isn't a 40,000 technically when I turn it to 2, it's actually negative 8. Now, at this point, I should be able to factor that one side apart and read off what my final answer is. So this is negative 80,000 equals negative 2. And when I factor this thing apart, it'll be x minus, and it's always half the middle. Yeah, so it's always 200.
Squared.
In this case. That's squared. So my final coordinate, and again, because I'm factoring that trinomial, I always told you the shortcut is it's going to be half the middle. The coordinate for that, like the actual vertex for this particular problem, is what's the number with the x? 200. Okay. And the number with the y is
80,000 positive.
And again, you always do the opposite of those numbers. This is your x value that you're going to use as the dimensions on that picture where x is sitting. And this is the area. That's the maximum
Well, I
area.
thought you were gonna use 80,000.
So this is going to be 20,000, or sorry, 200, and then this will be 200 over here. So that means if that's a total of 200, that means there's 400 feet of fence left, and that would give me the maximum area. Now, if your barn isn't 400, you can shorten that up, and we can place the X here. So you can set like how big your barn is. So maybe your barn's only 100 feet long. Well, then put the 100 here, and we can maximize the area with the 100. So you can put the variables on the other side, and you can keep going. So the two other x's will be 800 feet of fence minus 100 minus the 2x, and that'll give you whatever's left, okay, for the dimension. Okay, so we can adjust this problem for any purpose. So even if you have a limitation on how big the barn is, we can always make a pen of maximum size off of it. I just picked one where I didn't care how big the barn was. So I just put x's and then I put the 800 feet, whatever's left.
If I was to make it, I'd have a
Okay.
one and one, and then
Okay, questions on how I set that up. Questions on how I complete the square. Now again, if your problem isn't a story problem, usually they just start you with a problem like this. And now you can complete the square. Maybe there's no story problem, they just give you a problem, you can complete the square off of that and give me the vertex. Remember, this is the vertex. It's where the bowl actually starts. So if we were to graph this number, right, graph this on a Cartesian coordinate plane over 200 up 80,000. This is the maximum graph, and it will be coming down like this. It'll be coming down, so we can actually solve. And again, how I know where it's going to hit is because there's a negative number out in front of the x squared, so it tells me the tail's going down. That's what the negative sign tells me. And then when I factor this apart, what makes both of these 0 is the x-intercept. So this would be 0. And if I plug the 0 in, whatever would make this 0, that would be, set that equal to 0, 800, so it would be 0 and 400. 0 and 400. Those would be like where my x-intercepts are if I actually solve both of these for 0. So I get kind of an idea where the graph is, the x-intercept. In fact, the origin, 0, 0, is where the y-axis, the y-intercept as well. Now, again, some people are like, all right, Ward, fine, I get it. Yeah, you did a random problem that, had a barn. Not everyone's going to do a barn problem. It's not practical. Okay, fair enough. So I was thinking about like a school-related problem. Instead of, feet of fence for a barn. What if you're thinking of a playground? Okay, you're saying a playground, and you have a certain number of fence that you want to use. So maybe you want to recycle some of the fence you already have. Okay, so one of the problems I was trying to think of was something like this. Okay, so, not a garden, let's go to the playground problem, where's that one?
Oh, yeah, that's a little fence.
70 to 70.
Alright, so rectangular playground. So this is another one I was thinking of when I was doing these problems. Okay, so you want to make a rectangular playground, but you want to divide it into two parts, like in half. So, this is what I consider one of the more challenging types of questions, this one in particular. Okay, so you have a playground, you're going to break it into two, so maybe the upper kids and lower kids go in kind of different areas of the playground. Okay, and you want to figure out the maximum dimensions for this enclosed area. You want to maximize their play area. And you're only using 400 feet of fence. So you're limited. So this is kind of small playgrounds. And so the idea is like, could we figure out the maximum to it? Well, yeah, it's possible. So I'm going to draw a mock picture of my playground now. I know I have a picture that'll pop up here later to show you kind of the idea. But you have a playground, and we're going to split it into twos. Okay, so there's two playgrounds. Maybe the big
Do they have to be equal size?
Okay. Now, The idea is that we're using a total of 400 feet of fence, and what makes this problem difficult is it has 3 fences. It has 3 fences. It has the X's going through the middle. It's not like the barn problem where there's only 2 on the
So
one
it's
side.
3x.
This has 3 X's going across. In fact, then the other 2 sides, and this is what gets really difficult, the other 2 sides are whatever the 400 feet of fence is minus the 3 X's
Divided by 2.
divided by 2.
Damn.
Because there's actually 2 halves to this fence. There's the top half and bottom half. We don't have a barn we're going up against anymore. So we have to take whatever the 400 feet of fence minus 3 X's, and we have to divide in half. In fact, if you want to figure out the smaller numbers, it's divided by 4. Not just 2 halves. You divide by 4 if you want to figure out the small dimensions. I'm just going to go up to the big ones. So I want to figure out what is the total playground, ignoring that weird line in the middle. Okay? So the dimensions of this, maximum area, you take the length, and we take it times the width, which if I divide these by 2, that's 200 minus 1.5x. I'm just going to write it like that, because that's dividing it by 2. Okay, does everyone understand, that's the area where I'm coming up with that number? Again, what's hard about this problem is, the setup. Knowing that you have 3 X's going across,
I just don't know why you separate it.
and you have the top and bottom being 400 minus the 3 X's divided by 2. This time you have to divide by 2. This.
Can't they just play together?
Now, this problem would solve exactly like the other ones. Now, again, you have decimals, not a big deal, but we can actually solve this. In fact, let me get rid of this story problem here. Okay, so we can actually take some room here to solve. All right, so to solve this out, so y equals, I'm going to multiply these together. Okay, so solving this out, this is 200x minus 1.5x squared, if I just FOILed it out. And again, remember, the dimensions. X is the dimension for my playground, the parallel walls. And then the y number is the area that we're going to find, the total area of the playground itself. So if I rearrange this thing to make it a little bit easier to look at, negative 1.5x squared plus 200x. So I'm gonna factor this negative 1.5 out so I get the x squared by itself. So if I plot the negative 1.5, I have to take 200 and divide by negative 1.5. Can somebody do that in the calculator for me? 133.3 or repeat it.
3.
X. Okay. So that's, and that's negative by the way. So that's taking 200 divided by 1.5. Negative 1.5. That's where we're getting that number from. Now, if you don't like doing that, you could have left the fraction of it, and that this number would have been, what would that have been? It would have been 400 divided by 3 or something like that. So. Okay. All right. Now, complete the square. Half the middle. Square. So half of 133.3, and we square it. What do you get? Say again?
4,444.4.
4,444.4.
Yeah.
Okay, all right. And that, is that the number that you get when you take half the middle and you square it?
Alright, that seems.
That's
Okay.
what I got.
Okay, take this number times the negative 1.5 out front. So it'll be negative.
Yeah.
So 4,444.4.
Negative 6,666.6.
Holy, that's
Wow.
not a lot of. That's
the double right there.
Lots of sixes. And again, how are we doing that? Half the middle. Squared is that number. Take that number times the number outside, which is negative. And that's the number we got. And so now we can factor that whole thing apart,
Alright.
which, if we factor this correctly, it'll be x minus, and whatever half the middle is, half of 133.3.
50 point, add 50 to 16, that's, 66.666667.
Is that what it was?
Yeah.
Okay, and then on this side, this is 6666.6. All right, so now the actual vertex here. Because again, half the middle squared, when you factor it apart, the factor of this trinomial is always half the middle, that's how I know what it is. So your coordinates for x, that's the 66.6, because I always put the opposite of that number. And this is my biggest area that we have.
It's quite the ironic.
Alright, that would be the dimensions. So, the x's are the numbers going up, so this is about the fence line. If I'm using 400 feet of fence,
They would round down.
these are 66s, maybe 67 feet, maybe or
You can't run
66
out.
and a half.
You run out.
So, you just pick 67 feet, and then the idea is that this is whatever's left over, and you just make it work. Okay, I would say, just to, like you guys were saying it, just to be safe, always underestimate. So say 66.
So your fence doesn't line up?
Yeah, it won't like touch in the very end. So I would say like you're gonna make this, and you know this is your dimension, maybe pick just these walls as 66 feet, like even, don't put the 0.5. Make them 66, that way you have a little bit extra for the other side. But again, how do you know like what's left? Well, if these are 66.6 or 66 even, you can figure out what's left of the
We need to subtract
of the 400, because yeah, you take 400 feet of fence, minus the 3 66s here, and then divide that number by 2, and that should be your top dimension.
101.
Okay. What?
101.
101. Okay, so the top and bottom should be 101 feet.
We need to divide that by 2.
101 feet, 101 feet.
55.5.
Okay. For the total, that's total going across. That means, you know, these numbers here are roughly 50 and a half. 50 and a half, 50 and a half.
So it's
50 and a half.
oblong.
So, not very big. Because again, 400 feet of fence isn't very long, you know, schools
They
full of
should have been wiser and not put the divided children. And then they could add more to go around.
Okay.
We are wasting our
All right.
funds here. Do you guys not see
Okay.
the issue?
Hey, we good with like how the weird numbers turn out. Again, it is a practical application. You can make a playground with a bare minimum number of fence. And you can make it 2 playgrounds or 3. And I could keep expanding upon that. But again, it comes down to like, do you understand the concept? That you're multiplying dimensions together, and it is a quadratic. You know, it does have an x squared in the graph, so that we can actually solve it. Even though these were crazy decimals, it still works. We still can use shortcuts to figure out the actual dimensions and area of it. Now, again, not practical. No one's going to do something like that, or make 2 playgrounds off of something like that. They just make 1 playground, trying to maximize the area that they can get.
Do they actually do that, or they just say, we're just gonna kind of?
They don't actually like do all those calculations themselves. They would just hire some other group to come in and make the fence for them, or yeah, they just hire. But if you want to know like what you could do yourself, like this is practical work that you could do. And I don't think it's that difficult. It's just that some people wouldn't think about it. They didn't realize you can do something like that with some simple math. I consider this simple math. It is. It's just practical. Story brown back up. There. Okay. Now, the last one I'm going to show you here in a little bit, and I'm going to show you the picture of this one here too, because this is the playground I was talking about. So you had 2 playgrounds, and they were trying to maximize the area for the city.
circular.
So they were trying to put a fence around it. Put a fence down the middle of it. Yeah, that type of
I
thing.
feel like
Not
we
a
just.
rectangle.
It can be.
No, we say that the green grass in the middle is the playground.
All right. Now, we did find the maximum area. That was the 6,666 feet, right? Now, what we're going to do next is more business application. Like if you're in a small business and you want to maximize profits, that's what I'm going to do next. This one, I like this next problem way more. This one makes more sense to me than the playground problem. But I want to show you, like, there is things we can do with it.
The playground problem makes sense, so we split them.
Okay. Okay, we good? Does anyone need that problem still? Okay, alright, so, ignore that one. There, this one. Okay, I'll let you write this problem down.
Maddie Olben, come to the office, please. Maddie Olben.
Okay, so this would be like a business type problem where you're trying to maximize costs, so you can get maximum profits. Alright. So, now this would take a little bit of research to put something like this together. Obviously, you'd have to, get some polls going or take some data over long periods of time in different areas. But, you get roughly 8,000 passengers a month, on this airline, whatever it is. And they're paying about $60 a ticket. Okay, now, the market survey indicates that if you increase the ticket by $1, so $61, that you're going to lose 100 people right off the bat. Like 100 people are gone instantly. Figure out the maximum revenue that you can make you know, in a month. So
Just
there's a
do that.
sweet number there, right? Like you don't want to charge $60 because you're only going to get your 8,000 passengers, right? You're going to take 60 times 8,000. That's, you know, that's a baseline. But if you start increasing your dollars, there is a sweet spot where you can make maximum profits, but you know you're not going to get your 8,000 passengers.
Oh, that's depressing.
Okay, so that's the idea.
What if you
Right.
care more about the people, not about the money?
Well, there you are.
Okay, so I'm gonna kind of walk through this problem, and this is kind of like a real life business type of thing where, you know, like a local business could ask somebody to do this for them. Like, if I increase the coffee here by 50 cents, and I get maybe half the customers, where's the sweet spot at?
Wait, how do they
You
do
know.
that market survey?
This would be just it's trial and error, really. You try to select locations, you try different prices, you try different discounts at different places, and you see kind of what works, what can sell. That's why, like Target and the major market, like the major like shopping centers, they give you different ads depending on your area. Like it's not the same ad across the U.S. Like, because that's why when you go to their website, they say you have to type in your zip code, because you get different sales depending on what state you're in. Car dealers do that too. If you go to like California, to get a lease or a loan on a car is way cheaper on like super expensive cars than in Iowa, because they get more market out there, so they can charge less money for it. It's just kind of weird. They figured out a sweet spot of what they can charge. So here's the idea. This one, I consider this to be a challenging problem, because you have a lot of like things to think about. So here's the idea. If you increase your $60 price tag by so many dollars, I'm going to say my X's are going to be my increase in dollars. So if I go 3, that's $3 increased, right?
Minus 100.
I'm going to lose 8,000 passengers.
Yeah.
Or I'm not going to lose 8,000. I'm going to lose
Minus
100
100X.
passengers per X that I increase it by.
That's awesome.
Okay, for every X I increase by, I'll lose 100 passengers. So if I go $3, this will be 300 people coming on
300.
out of the plane. Does that make sense how I set that up? So for every dollar increased by 60. Now why I'm choosing to write it like this? When I multiply the price times how many people are on the plane, that gives me revenue. So this is my function. This is my revenue for this particular business. Because that's how you find like you know profit or total sales. You take however many items you're selling times the price of the item. That's what we're doing. Taking the price of the item times how many we're selling. That's how many tickets. So, right? So if we FOIL this all out, and yes, we do have to FOIL it out. So 60 times this. Well, that's
a big
a
number.
big number. 48 with 4 zeros after it. Okay, so it's 480,000. And then we're taking 60 times the negative 100, so that's negative 6,000 x. And then x times 8,000, that's positive 8,000 x. And then x times negative 100, so that's negative 100x squared. Okay, so there's my function. Let's simplify it. I'm going to replace it with a y. And I'll kind of move some stuff around so it's more like the problem that we're getting used to. So I'm going to move that 480,000 to the other side, because I do need to get the x's by themselves. And now that negative 100 is going to come up here. This number, if I add those together, that is 2,000 x's. So that's simplifying this problem down to where we're going to get. Now, again, what this thing is going to do is it will give me a maximum answer, a maximum profit, a maximum revenue. How I know it's going to be a maximum? What's the number in front of my x squared?
Negative 100.
Negative. So this graph is doing this.
No.
The tail's going down because it's negative. So that means I do have a maximum to this graph. There's a sweet spot on the graph that is right at the top. Top profit. Now if that was a positive in front of the x squared, I have a minimum to the graph. Because the graph is going up, so there was a minimum number that I would want. So, alright, but now we have to factor out all the stuff here. So because I don't get the x squared by itself, there's a negative 100 out front. So if I factor out the negative 100, this will be x squared. If I divide that by a negative 100, that's negative 20x. And over here, I'm just going to leave this negative 480,000 alone. Alright, and now half the middle squared. Half the middle is negative 10, we square it, that's 100.
100.
we take that times the number on the outside, which is
Negative
10,000,
10,000.
and, negative, and then we're gonna put it on the other side, so we're gonna put a negative 10,000 over here. How I know it's 10,000? We take 100 times 100, there's 4 zeros, that's how I know. Kinda what
That's
it's gonna be.
quick math.
Alright, and now, kind of completing this workout all the way, the y number is gonna be negative, 490,000, if I subtract those, they're both negatives. And on this side over here, I have x minus 10 squared, right, because half the middle, that's the number inside the parentheses, if I factor that trinomial apart. And so, what is my x? What's my vertex? What's the x number?
Negative.
10? What's the number with the y?
490,000.
490,000. So, the idea is that on this particular problem,
If you
this is
increase
what I
that
should
x-
increase my ticket price by.
Geez, $70.
So, yeah, it should be $70. I'm increasing my ticket price by $10, and that should be maximum profit.
Do you think most
That's
airlines
the idea.
do this?
What?
Do you think most airlines do this?
Now, I'm sure there's somebody in the industry that probably does do this for them. A local business probably wouldn't do that. If you're in this area, this is some practical math you could do on your own to figure out like the sweet spot for prices. But I'm sure there's got to be somebody getting paid to do that for their business. Doing the actual market, like the research and stuff, and putting it all together and trying to present to the executives, like this is what we should do. I mean, Apple does it. They jacked up the iPhone prices by $50 recently. They know what they can squeeze out of people. So,
Sure, I'll still get one.
but again, this would be like the maximum revenue. Like you make 490,000 just by increasing by $10. Now again, by increasing by $10, I'm gonna lose 1,000 passengers. But I'm gonna make more money. That's the idea. Okay, and I could make this problem up by, I just increase by $1. I can make that any number I want. Okay, but here's your, and again, I know I have a cool picture to go with it. Your cool pictures are
Airplane,
awesome.
sorry.
Alright, so, but, homework today. I'd like you to write this down. Because I did promise you were gonna get homework today. Okay. So, page 298, 1 through 8. Now, the 1 through 8 is really nice. They're having you match a formula with a graph. So you're getting used to like, is the graph going up, is it going down, where's the vertex at? 39 through 44 are getting used to like doing quadratic formula or completing the square. They'll kind of ask you to do one or the other. Figure out x-intercepts if you can. That's factoring. And then 61 through 74 are some of these story problems. I've done a lot of them already. Like the problems I'm doing on the board are the homework problems. You already have some of the answers.
That's awesome.
So, I only give you one kind of challenging one. It's kind of the airplane problem. I just changed the number.
For the divided playground fence and 50.5.
I'm going to make this assignment due Thursday this week.
Yay.
I know that's kind of a shorter turnaround for some difficulty like this, but we're going to still stick with quadratics throughout the week as we go through notes. Like tomorrow, we're going to be graphing different types of polynomials.
Oh my, one
So,
minute. That's
well, there you
like
go.
Ward, can you go back a slide?
Yeah.
No.
Do we have time to do this like last tomorrow?
A little bit, yeah. Now, I know I don't have time for book check because we have like 30 seconds. Bring your books tomorrow because everyone needs some time to work on it anyway. And I'm going to check your book. Make sure your covers are on it because I will check for that. So make sure of that. Now, if you have any late work or whatnot, make sure that you
You
get
have
that
to
turned in
inform
and
that
stuff,
Kobe
right?
is not going anywhere.
It's 905.
Mr. Ward, you think you can make more money if you subtracted money off of your cost and added more passengers? Or would you be better off to add money and lose passengers?
It depends on how much you're going to lose.
Yeah.
I mean, it could come down to like if you increase by $1, you lose
But Mr.
over
Ward,
half
you
the
jack up
passengers.
the price
Goes
to $70, another
Lower the
airline's
price.
gonna come in and undercut your prices, and then you're done.
You're
Then you factor
You're
in
finished.
No, you're done. You're done. Now factor in everything. Factor in the total economy. Factor in your president.